So this video is called The Basics of Exponents. We're just going to learn what exponents are, how they work, how you use them, the logic behind it, all that stuff. Okay, so an exponent is one of these little numbers up and to the right of these big numbers. And what that means is that if you have like 2 to the 3, and you say 2 to the third or 2 to the 3, something like that, it's the base and then to the exponent. That's how you think of it. So what this means is that you're going to take this base, it's the bigger number, and you're going to multiply to itself the amount of times that this exponent says. So let's see what that looks like. We're going to take this 2 to the 3 and multiply this 2 to itself, so 2 times 2 times 2. So this is 2 multiplied to itself, 2 times 2 times 2, 3 times. See how there's 1, 2, 3 2's there? Okay. And once you do all that, now you just have to do the math. So 2 times 2 is 4, that's these two, times 2 is 8. 4 times 2 is 8. So this is going to be 8. Okay, we can do the same thing with 2 to the second. It's going to be the number 2 multiplied 2 times, because that's this 2, and then this 2 is the amount of times that you multiply to itself by. And so we already know that that's going to be 4. And then this 2 to the first power, well, that's just 2 one time. You can also think of it like 2 3 times. 1, 2, 3. 2 2 times. 1, 2. 2 1 time. 2. So this 2 to the fourth power, if you might have guessed, there might be a pattern going on. So that's going to be 2 times 2 times 2 times 2. See how there's just kind of like, a different row or a different column every time? And you're going to get 16. Okay, so now I'm going to kind of do something crazy. See how when we're going up, there's a pattern here. It goes 2, 4, 8, 16. You're just doubling this every time. So you can probably guess what 2 to the fifth is going to be. It's just going to be this, but doubled. So it's going to be 32. But now let's think, what would 2 to the 0 be? Well, because the pattern is going like this, you're doubling it. Well, when you go this way, you're really halving it, right? 16 divided by 2 is 8 divided by 2 divided by 2. So 2, if you use that same pattern of dividing by 2 this way, then this is going to be 2 divided by 2, which is going to be 1. So 2 to the 0th power is actually going to be 1. That's pretty crazy. But what's even more crazy is if you keep going, right? This goes 5, 4, 3, 2, 1, 0. What about 2 to the negative 1? Well, if we use this same pattern, we're just going to keep halving this, which is going to be 1/2. So 2 to the negative 1 is actually going to be 1/2. And you can keep that logic. 2 to the negative 2, you're going to halve that again, so it's going to be 1/4, and that's going to keep going. So that's one way to think about exponents. Okay, so just like with the 2's, the 2 to the exponents, you can have any number to the exponent. So I'm going to explain the next kind of thing in terms of the base of 3 to any exponent. So we're going to have 3 to the third, which again is just 3, times itself 3 times, so 1, 2, 3, and that's going to get us 27. Next, we have 3 to the second, which is 3 multiplied by itself 2 times, which is 9. Same thing with 3 to the 1. Okay, same concept with this. If our pattern is every time we go this way, we're dividing by 3, and so thus every time we go this way, we're multiplying by 3, which is literally what we're doing, right? We're multiplying an exponent by 3. Meaning, when we look at the pattern this way, we're dividing everything by 3. So 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1, and then 1 divided by 3 for this one is going to be 1/3. Okay, so we can continue on the same pattern, and we're going to know that 1/3 divided by 3 is going to be 1/9, and 1/9 divided by 3 is 1/27. But I want you guys to look at some similarities that are going on. We have 3 to the third is 27, and then if we look at the inverse of that, 3 to the negative third, well, that's 1/27. And 3 to the negative half is 1/9, and then look, 3 to the half is 9. So you can kind of think of these negative exponents as, well, A, you're going to know that they're a fraction, And B, you're going to know that the denominator of the fraction is just whatever the positive exponent is. So this can really be written as 1 to the 3 halves. And oh look, we already know, it's 1 over 3 to the second. And we already know that 3 to the second is 9. So that's still going to be 1 over 9. And that's why when you have a negative exponent, it's always going to be a numerator of 1, so just a unit fraction, over the positive form of this. Okay, so here are some example problems that you can do on your own. You can pause the video here and do them, and I will be explaining them in just a second. Okay, we're explaining now. Okay, so first off, and make sure you try the challenge problems. Okay, so first off, we have 2 times 3 to the second. Okay, so remembering PEMDAS, and if you don't know PEMDAS, go watch our other video, but remembering PEMDAS, you have to do parentheses, exponents, multiplication, yeah, all that good stuff. So first, we have exponents, and look, we have an exponent. So this is going to be 3 to the second, which is 9. So we're going to have 2 times 9, which is going to be 18. Not so bad. Okay. Same concept here. We have exponents first, so 2 to the third, which is, again, 2 times 2 times 2. 2 times 2 times 2. It's 3. It's the 3 in there. And that's going to be 8. So we're going to have 3 times 8, which is going to be 24. Okay. Now, this one's kind of funny. So we have 5 plus 1 to the power of 100. So when you're thinking about this, like, if this was, like, 2 to the power of 100, that'd be like, oh my god, I don't want to do this. But this is 1 to the power of 100, which is literally just going to be 1 times 1 times 1 times blah, 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 until you do that 100 times. And it doesn't matter how many times you multiply 1 times 1. You know it's going to be 1. So this is going to be 5, literally just plus 1. And that's going to get us to 6. And this could be 1 to the 1,000,000th, and it's still going to be 5 plus 1 is 6. Okay, this one was a little trickier because you had to include the negative exponents. So, if you remember, 9 times, and then 3 to the negative 1 is just going to be 1/3, right? Like, you just put the 1 on top, and then the 3 to the 1 on the bottom. So actually, let's include that. Put 1 on top, put the positive of this on the bottom. So that's going to be 9 times 1 to the 3rd, as we already said. And that's going to get us to be 3. 9 times 1/3, or 9 divided by 3 is 3. Okay, this one's also pretty funny, because this could be literally any number in here, and as long as it's to the 0th power, this right here is going to be 1, as we already said. So this is literally just 1 plus 7, which is 8. Okay, cool. This one, same, this is when you have to really start thinking of it as like 1 over the positive version of this. Because you could, like, do our usual, see the pattern, just like keep dividing it by 2, but it's a lot easier to just look at it like this. So, 1 over 4 to the second. 4 to the second is 4 times 4. So 1 over 4 times 4 is 16. So this is just going to be 1/16. Hopefully that makes sense. Okay, and now we're going to have the challenge problem. So this is tricky, right? Because we have 1 over, and then a base, and then another negative exponent. Okay, so we can do this a couple different ways. Let's just start this logically. Knowing what we know here, let's just try to solve this. Okay, so we have 1 over 3 to the negative 3. We know that 3 to the negative 3, just by itself, we know that 3 to the negative 3 is going to be 1 over 3 to the 3rd. And we know 3 to the 3rd is 27, so this is just going to be 1 over 27. So that's this bottom part. This is going to be equal to 1/27th, right? So now we have 1 over 3 to the negative 3rd, which is 1/27. You can rewatch that if you didn't get it the first time. But now we have 1 over 1 over 27. So whenever you're dividing fractions, you got to do the keep, change, flip, right? So we're doing 1. That's keeping it. Change, we're multiplying. And then flip, this 1 over 27 is just going to be 27. So it's just going to be 27. That's one way of thinking about it. Another way of thinking about it is, this is kind of just like a trick. Whenever you have a negative in the denominator, you can actually flip the whole thing and just have this, whatever's in here, put it on the numerator and make this negative a positive. Another way of thinking about it is using the same logic as 3 to the, like just a regular 3 to the negative 3, or anything with a negative is the same thing as 1 over the positive of that. Well, 1 over 3 to the negative 3, see how we flipped this sign and put it in the numerator? All we're doing is, in the denominator, all we're doing is flipping this sign and putting it in the numerator. So whenever you have a negative, all you gotta do is flip the sign and then switch whatever position it is. So this is just going to be a regular 3 to 3, which we know is 27, which is what we got here.